Hello, welcome to Elimination in a System of Nonlinear Inequalities. My name is Anusha. So let's go back to the basics for a second. We have learned elimination before with normal equations. Our aim is to get rid of one of the variables so we can solve for the second. As we can see with this example, we eliminate the x variable so that we are only left with the y variable. Once we have only one variable, in this case the y variable, and a constant, we can solve for y. In this example, y equals 3. If this concept doesn't make sense to you, Expii has some awesome lessons on elimination. So now that we've covered the basics, we will take this a step further, but with nonlinear inequalities. Remember, the goal for elimination is the same. We want to eliminate a variable in the inequality so that we are left with only one variable. There are three main things to keep in mind before diving in. First, elimination will only work if the signs are in the same direction. So you can have two less than signs or two greater than signs, but you cannot have a less than and a greater than sign. Second, we can only use addition for elimination. If you think back to elimination techniques like the ones we just reviewed, we can either use subtraction or addition to eliminate a variable. However, with inequalities, if we were to do that, we would trigger a sign change. So we can't have that. So we only deal with addition in the elimination with inequalities. Lastly, same as with normal elimination, we want to stack the like terms on top of each other. So let's take a look at these 3 points in action. We will not try to solve this system, so don't do that. Just focus on the 3 points we were talking about. Our first point was the signs must be in the same direction. We can see that both inequalities are greater than, so we're good on that front. Next, we can only use addition for elimination with inequalities. That seems to be the case here too. Great. Now on to the third point. In the third point, we said that the like terms should be stacked on top of each other. We can see that the squared values are on top of each other, the x values are stacked, and the constants are stacked. We're looking good with this system. Let's look at this next one to check our 3 points. Don't try to solve this system either. We're just checking our 3 points to make sure that the system can be solved. Our first point was that the signs must be in the same direction. We can see immediately in this system that the signs are not in the same direction. The first inequality is less than, and the second inequality is greater than. Oh, sorry, I have those flipped. The first inequality is greater than, and the second inequality is less than. So we already know that we can't use elimination to solve this system, but let's check out the second point anyway. Our second point is that we can only use addition for elimination with inequalities. We can immediately see that this isn't true. Yet another reason we cannot solve this system. Lastly, with elimination of equations, we want the liked terms stacked on top of each other. That's not the case here. The quadratic term is stacked on top of the linear term, and the linear term is stacked on top of the quadratic term. The constants aren't stacked on top of each other, though. Even then, the nail in the coffin of why we cannot solve this system. Now that we've figured out how to check if we can even solve this system of non-linear inequalities, let's work through a couple of examples. We won't be using any graphing, but we will set up the problem using elimination only. Here's our first example. Before we dive into the real mathy part, let's first run through our 3 points again. First, we can see that signs are pointing the same way. Perfect. Next, we can see that this system uses addition. Great. Last, we see that all like terms are stacked on top of each other. Brilliant. We can move forward with elimination. We can see that the linear terms are additive inverses of each other, so we can eliminate those. We can add the rest of the terms, and we get this final inequality. Let's do some more practice eliminating. Pause and try this one on your own. It looks like our first point is good. The inequalities are facing the same way. The second point also looks good. We are using addition for this system. For the third point, the first thing we want to do is align the like terms. Then we can start eliminating. This is what it looks like. Check your work. Thank you.